We're going to talk a little bit today about performance engineering. And we're going to show you some things that are new and different, hopefully. And it'll be a good use of your time. Please save questions till the end. We'll do a Q&A at the end. My name is Steve Lerner. I'm the Director of Sales Engineering at Product Science, which is a new company, about a year old. And I'm employee number 10 in the US. So I've sat through a lot of these, like you're sitting through now, over the years, and I always sometimes wonder, like, is the person talking credible, right? So here's just a little bit about me. I'm gonna tell you a secret, though, that not even my therapist knows. I'm not a mobile app developer. I am a performance engineer that has worked across all kinds of different stacks. Even before there was internet, actually, working on electronics and sound engineering equipment. But I was, first kind of known for building streaming media networks, including the one that's the pattern that Netflix and everybody else uses. I built and designed and patented that at a company called Speedera, which is a content delivery network that was acquired by Akamai, and that was almost a unicorn. And then I joined eBay and ran all of the sort of performance engineering at the front end of their network. So this was operating and building the entire content delivery network system, the whole edge. I converted eBay to HTTPS and enabled HTTP2. And that was $85 billion of e-commerce. That was in like the mid-2010s. But eBay didn't want to go to cloud, and I thought cloud was the future. So I looked for the hottest cloud startup I could find to join. It was called Signal Effects. They were doing real-time observability, basically taking cloud metrics in real time, unlike everything else that was sort of a batch and query. And they also stumbled on the ability to do application performance measurement, APM, and instrument Java apps, and in fact, any kind of language, and use an open standard called OpenTelemetry. And that was my unicorn. So we were acquired by Splunk for $1 billion. That was in 2019. And I spent a lot of time with APM, a lot of time instrumenting Java apps and .NET apps and Python apps, and I thought that became my specialty. And I got a call from some friends, and they asked me this question. They said, "You have done performance engineering your whole life, right?" I said, "Yes." And they said, "And you specialize in instrumenting applications, really complex, difficult applications, and working in any kind of language on any platform from mobile to servers." I said, "Yes." And they said, I'm working at this startup, and I think you might be interested." And that's how I got to product science. And we're gonna talk a little bit about things from sort of this perspective about performance engineering and how it relates to mobile apps and sort of how to do it right. Because coming from working with every kind of application measurement tool and tracing tool across Fortune 1 down to startups, notice that the mobile world has sort of been left out until now. So what is mobile app performance? And why should we care? Why are we sitting here? What does it matter? So what I notice, because I'm not a mobile app developer, is that a phone looks like the cloud. It looks a lot like AWS or GCP or Azure. It has different sort of physical components like cameras and storage, and in fact, they even call things containers on a phone. There's different languages being used in different parts of it. There's different sort of abstraction layers. It looks a lot like a cloud. And so what I notice about a phone is that today's ability to sort of analyze a phone's performance is a lot like the cloud's was way back in the day. It's chaos. There are logs and system traces, and it's a mess. And if you're trying to do performance engineering and analyze your app, it's not easy to do. There are not a lot of sophisticated tools out there until now. And what's happening is people are doing real user metrics. They're installing sort of monitoring code libraries that are emitting metrics to Datadog or to Splunk, and your problems are found by the DevOps people, and they get all the pizza. And then they call you and say, "Fix your slow app," while they're eating the pizza because they caught the problem. And that doesn't make sense to me as a performance engineer. So it's, the reason it's hard and that it's overlooked is that, it's just because it's hard to do. Phones aren't made to do this yet. And apps get slow because you sort of forget about it, and you're developing, and maybe you look at it, maybe you use a tool, maybe you do that, and the apps get slower and slower. And let's be honest, Okay? This is Samsung S22 Ultra. This is the newest, fastest kind of phone you can get, and I see slow apps all the time. Even from mainstream, like, important people, like airlines, when I'm trying to like switch a ticket because my plane was canceled, and I'm sitting on the plane and I'm trying to book a new ticket, and the app is slow, even though I have 5G, and 5 bars. And I know this is DroidCon, but this is also true for iOS. So you secret sort of closeted iOS developers in here, like that also do it on the side, side hustle. This goes across both. So why we care about this is that performance, even small aspects of performance, impacts our daily active users. Now, this is a highly abstracted chart about daily active users on the y-axis and years on the x-axis. And the reason it's highly abstracted is because it's a true story of one of the top 5 social network apps that started to see a radical decline in daily active users and a radical decline, no guessing, okay, a radical decline in stock price. And they hired a team of people, or they acquired a company, and they put that company in charge of performance engineering, and they went after everything performance. And once they turned around the performance of the app, the daily active users increased, and so did the stock price. So it's very real. Small aspects of performance across our whole app make a difference in terms of money, and in terms of customers, and in terms of our livelihood. So performance is important. That's why we care. And why is optimization important? Because customers. And you guys have seen these numbers. I put them up here so we can look at them again. They're all sourceable, but people have a lower, impression of a brand if the app stinks. I mean, they just do. Like, you start to think of this brand as like bad because their app is bad. And brands are important. We think about the things we use every day. We had someone come by from an app that I use to book exercise classes at this British boxing gym. And I'm glad they came by and we can talk about performance because I care. I actually like the app. I think it's really cool. And I think it's cool that it has my British boxing gym on it. So I care. There's a brand. This guy had the t-shirt from the brand. It's that's great. And this is true for billions of people now on the planet. So how do we deal with this? All right, we all know it's a problem. We're all sitting here. We're all engineers. We're all together. Well, I like to talk a little bit about the theory behind things before I talk about the practice. So the theory is that the APM, application performance measurement tools, the server and DevOps teams, they have the cool tools. They're able to do this. I'm not allowed to walk. Usually I walk in front of a screen, but they told me not to do that. But I usually walk in front. But they have these cool systems that show a transaction going to the front end. Wait, does the mouse work? Okay, yeah. Going from the front end, passing through a shopping cart, it calls a database, it calls checkout, and they can see the slow part of an individual user's transaction, and they can find exactly where the problem is and link to the code that's running and do code profiling. The DevOps people, they have this, right? But what do we have? Okay. I know there are people from Google here. Okay, but straight up, your video guide for Android Profiler on YouTube is from 2017. And that's okay, because that gives us an opportunity to build aftermarket tools and be a partner and part of your ecosystem, right? I mean, we wouldn't have the opportunity to improve upon Android if you didn't give us the opportunity. So thank you for that. But the tools we have are legacy that are out there in the market. And as we can learn from the server people, just looking at things sort of in a static view doesn't work. You need to look at this whole transaction all the way through. And you can look at it on a mobile phone, and we're gonna show you how. Because new tools have arrived for us in the mobile app world, which I've now entered, that are as cool as what the DevOps people have. So how is it done wrong, right? The session's about right. Well, let's look at wrong. So the first thing that's wrong is manually instrumenting your app to try to find problems, all right? That's a huge waste of time. You're doing a lot of builds, you're doing things that aren't shipping features because you're trying to find problems. And that's not really what we need to be doing in today's day and age when there are much better ways of doing things. And it's highly limited. There's a typo here. It's highly limited in that a static trace shows you how long a function's taking, but it doesn't show you why it's slow. That, it shows you what's happening. Either a stack trace or an Android profiler trace or Xcode instruments. You can take a snapshot of the CPU executing code and know that something took an amount of time. That's what's happening. That's great. That's nice. but why? Why? Why did something slow down? Okay? Even if you compare one static trace and you make a new build to another and you do regression, that's useless because you don't see why something changed. You're guessing. And it's a waste. And there's much better tools for server stuff that we can now have. And I have this example here, unhelpfulprofiler.com, which shows a main thread and worker threads and amount of time that functions take, but so what? That doesn't help me. It just shows me what's going on, not why. And I still have to spend hundreds and hundreds of hours digging through logs and traces and manually instrumenting to find a problem, and that's wasteful. So people then say, well, you can just use real user metrics and, find the problem there and get some kind of indication. But by the time you need to monitor a problem, it's too late. Why are you doing monitoring? Why not fix the problem in pre-production? Why not have tools for us in pre-production and solve these things so that the DevOps teams don't get all the glory? So how do we do it right? So the first thing to do performance right is use automatic instrumentation. It should be a Gradle plugin. It should be a code injector for iOS, for Xcode. You shouldn't be adding in anything to your code at all. You should not be typing things in your code in order to be able to observe it. In today's day and age, and all of the server market has mastered this already, in the mobile app world, you should also do not use manual instrumentation, avoid anything manual, use automatic. Second, beware of anything that samples. Okay, there are things that happen on the mobile phone that are so quick. There are libraries called so fast, millisecond, 2 milliseconds, that if you're sampling from the CPU and you're not instrumenting every single function that happens, you're gonna miss what could have been the cause of delay. So you need to instrument everything. Look, our guy from Google's nodding his head. He's like, yep, I see that. You're gonna miss what's going on. So you have to instrument everything, okay? And not avoid anything that samples. And then you should, as you study your app, break the problems down into something simple, a user flow. Okay, look at a user flow. You click a button and the screen redraws. Just study that. Don't try to study a 30-second long transaction, because the phone is gonna make so much noise that even with something intelligent, you're gonna wind up getting lost. Just start simple. Break things down into a user flow and see why it's slow. Right? You want to use tools that, for example, in this illustration, which is helpfulprofiler.com, that can link in a stack trace. Does anybody see a stack trace kind of profiling picture like this and not know what this is? Should I take a minute and explain what this is showing? Raise your hand if I should explain what this is showing. Okay, all right, it's cool, right? We're all in this together. I'm not even a mobile app developer, okay? So I'm learning too, even right now, because people are nodding their head or they're frowning, and I'm like, it's helpful. So this would be the main thread right here of your app. Okay, this would be a thread where something's dispatched to. Time is on the x-axis, threads are on the y-axis, and these are functions. And what you can see here is, and we're gonna dive into this more, what a helpful profiler would look like. This function or framework that's calls the next one. And this one dispatches something to another thread, and that calls the next one. So I'm seeing on this helpful tool what calls what, why something is happening, which function calls which function, where does it go, is it dispatching to a thread correctly, and I can see why. Why is slowness happening? Okay? So let's look at an example, a live, real example of a real app that has a real problem, why it has a problem, and the right way to troubleshoot this kind of problem, okay? So this is a demo app that does something very simple. You click one button, and it brings up another button, and then you click back. Okay, so I'm gonna play this. Click, and there's a lag. And then click back, and it's fast. Click, and there's a lag. So there's a lag after this next button. Now this could be anything in your world. It could be trading a stock, booking an airline ticket, booking an exercise class, finding a babysitter. Everybody's like, babysitter, I don't have kids. Then finding a date for those who don't have kids, or who do have kids, even better. So, this is the essence of it, is when the app is not performing in some place, okay? So what happened here? Why is this happening? So this is the part of the code where the button is calling the next button. Next is calling previous. And this someone, who's not a mobile app developer, tried to do this correctly with a Kotlin coroutine and execute the button call in parallel while the app was doing some work. The work is simulated by thread sleep, because that's what I've done for like 30 years, trying to simulate work, and a performance example is I sleep something. It could be any kind of work though. It could be fetching data, it could be anything. But what I'm trying to do is make the button click to the next button while the work is being done, and I thought I was doing this right. I opened up the Kotlin manual, the nice Google developer documentation, thank you Google, looked great. I thought this was right. You know, this is parallel execution, right? But there's a lag. So performance done wrong would be trying to open this up in a profiler and surfing for hours and rebuilding 1,000 times and looking at logs. That would be done wrong. But what if I could actually see what is happening here visually and use a tool that has a visual connection where this function here, and we're going to zoom in. This is a zoomed out view, okay? A function is dispatching work to a thread, but I can visually see it's operating in series, not in parallel. There's a lag. This is the wait, button calling button, but there's this lag. It's not dispatched correctly. I hear people say, you know, something's weird with the main thread. Like, it's supposed to be dispatching, but it's not dispatched. I hear that all the time. What if you could see it visually and forget the static trace analysis and look at your actual user flow about what is calling what and understand why? Okay, so let's zoom in a bit. So I can see here, there's my first fragment, and here I am. So there's clearly something wrong in the way I'm doing this dispatch. So forget the guess games, forget the logging and the thousands of rebuilds. I now know where to look, and I now know to reevaluate my understanding of Kotlin coroutines, which is basically zero because I'm not a mobile app developer, and I just learned Kotlin like 2 weeks ago and made this demo, okay? So what I discovered here was that I had this in the wrong scope. So I had my button motion, I thought that it would deploy correctly to the thread with, you know, if I had it here with this dispatcher, but that was wrong. I actually needed to have this work dispatched separately and have this run in parallel. I was one curly brace off. How many of you have spent more than 8 hours finding something that was one curly brace off? Okay, be honest. All right, come on. At the end, right? We're all going out after a party in New York. We can be honest with each other. We've all done this. And I've done this a long time with a curly brace or whatever. It's really embarrassing. Thank you, Visual Studio Code, for making life easier and having colors. So I can save the hundreds of hours and just, I saw what was wrong. I can reevaluate this very quickly. Rebuild my app and run it again, and now it's looking more sensible. Now, to your eyes, of course this is logical. Now, look at this. Button calls button, and that work is dispatched correctly in parallel, and everything's moving fast. But unless you're using a tool set that can have header propagation and trace correctly, like the big APM ones do for a mobile app, you can't do this. And you're going to be stuck with manually instrumenting and legacy tools digging forever. And if you zoom in, you can see it working correctly now. This frame, this choreographer, is not held up. Right? It's not held up by the incorrectly dispatched task that's going up here to this dispatch thread, main thread here, dispatch thread here. So this new way of thinking, performance done right, is thinking about things in a different way. Thinking about the flow, like a movie, of your code running by, and thinking of the tasks that are dispatched that are happening, right? Someone's going to get popcorn while the movie's running, and someone's going to get Coke while the movie's running, right? And someone has a critical phone call because the date that they just met from that app woke up with them, and so things are moving in parallel, but you can see the plot as it goes along. This is how to think about performance, not in terms of static frame shots and guessing why something is happening. So, Steve, you say, that's a nice demo app for you that you wrote, even though you're not a proper Android developer. How about in the real world? Well, thankfully, I have proper Android developers on staff at our company who can help with a better example. So, first of all, let's look at the app real quick. I forgot that I did this. So now you click next and back and forth, it goes quickly. So problem solved. But that's not a real world example. We ran it twice because it's so quick. We'll get to the next one. All right. So let's go to the real world, way past my code development skill set, okay? And look at something big. So here's Signal. the messaging app. It's an open source app, which means I can use it as an example, because I'm not selling it to you, so I can just show it. And we have here this interesting flow where the camera is causing, there's a delay at the end of the camera. You can see a frame counter there. There's this sort of like delay between the end of the camera and the chat. And it's a little bit hard to see on the video. It's gonna be easier to see when you think about performance correctly, which is that the user clicks the end call button and the screen takes a lot of delay, about 600 milliseconds, 43% of the user flow time, to get back to the menu. So performance done right. We're thinking about a user flow and we're thinking about these delays. All these little delays add up. They can add up to minutes, hours of user time. And we want to minimize them, so we want to think about it in that way, right? And the reason is because when you're using a tool where you can see how the functions are connected, after that end call button is pressed, there are functions that are triggered. You could see it right here. Audio manager, right? That are triggered to stop the audio. Signal audio manager and camera 2 session, they're right here. But I wouldn't have known that they were related if I was using static tracing tools. I wouldn't have made that association necessarily. I would have had to spend gazillions of hours to try to figure that out. But if you can think of performance as a user flow, as an application measurement tool that's tracing from function to function, filtering out all the noise of things that you don't need to see, you could think about performance differently, and it visualizes and it works much better. Okay, so there's this delay after the camera happens where the screen turns dark. There's also token credentials coming. So there's, all you see in a tool like this is these little thin frames going. This is a black screen. This is Choreographer and Android drawing frames, basically waiting for things to happen. So we've got several different delays here. Now, because I could see this visually, what's connecting to what, we now know where to go in the code and look at it in a better way. And what was found, and this is sort of what we call the possible reason, meaning there aren't necessarily deterministic answers immediately. What there is a guide on where to look, because everybody's code is different. We don't try to guess what you're doing. We didn't write Signal, but we've discovered when we looked at that audio function, right, that there's this delay built in to the app of 1,000 milliseconds. And so the theory we have is that was put there to allow the phone's audio components and camera components to shut down correctly. Okay, but that might have been done a long time ago when that was necessary. Today, it might not be necessary. So we can rebuild the app without that delay there. So let's look at what happened before and after. So this is the original, and let's see if it makes sense on a big screen like this. So hang up, it's that red button, and there's a second of delay there. Now let's look at it. We're looking at the red hang up button on the bottom. So we record the screen, hang up, and boom, goes back. Yeah, it took out half a second of time, 68%, between hanging up and getting back to the menu. But we were only able to find that because we thought about performance in a new way. We thought about what's connected to what, and then we knew where to look. Is it going to run twice? It's going to run twice. Okay. So they told me to talk for like 40 minutes. I'm talking less because it's Friday, and you guys can spend a lot of time asking questions, which I likely will answer, will be able to answer. So let's summarize performance done right for a nice quick Friday session here, and then all the Q&A you want. We've been left out in the mobile app world from the modern tool sets until now. It's time to start looking for better ways to pre-production while we're developing to study the work that we're doing to make sure that it's performant. Avoid manual instrumentation. If someone's telling you to start adding in code to your code in order to observe it, that's a problem. That's not needed. The server people, nobody does that. In the Java server world, in the .NET world, no one's doing that anymore. It's all, unless there's a very specific reason that you need to emit a trace for some key reason, automatic instrumentation is the dominant way. And if you look at the Gartner Magic Quadrant on the leaders in APM, all of them have the smoothest instrumentation. So the second thing that's important is understand the context between functions, threads, and user flows. So think about your app in terms of how people use it, and correlate that usage with the measurement of time and performance and how sort of snappy the app is, and then where things are running on different threads. Be able to visualize that connection back and forth to different threads. The dancing on the main thread, as some of the people I talk to say. And when you're doing your work, like, don't think of it in like the user using it in 2-minute stretches. Focus on like individual pieces and how long they take and how they're connected to each other. A lot of people I talk to say, well, it takes 3 minutes for the user to get to here and there, but that 3 minutes is really broken up of several buttons, several data fetches, several storage accesses, maybe an upload, maybe a camera, maybe this. It's actually broken down into several things. Like when like people wonder like how does Eddie Van Halen or Jimi Hendrix, like how do they learn their guitar solos that go on for hours? They break it down into very short chunks, and they practice those riffs, and then they string the riffs together. It's very similar when looking at a mobile app, is what I've learned, is that it's really many things strung together. This is the business of the app, is making that transaction happen, opening that camera. This is the business of it. And look at it in terms of the user flow, right? Don't simulate, use the app and look at it as a user is using it. And and my final thing, coming from DevOps, and giant Splunk with, it's billions of dollars of sales and all these huge DevOps departments, don't let these jokers have the last laugh. They love nothing more than to call up a developer and say, ha ha, we caught this, I got this alert, I'm waking you up, you gotta fix your code. Don't let them have the last laugh. Don't let them get to order food at midnight, when they're coming in. Solve the stuff pre-production. Think about performance in a new way, do it right. As you're developing, as you're refactoring, as you're creating, as you're changing, study your user flows. Incorporate performance engineering elegantly into your day with a tool that works with you and how your app works, and deploy your apps that are performant so that the DevOps teams don't get the last laugh. So I'm 3 minutes short of 30. That's what I got for you today at the last session of the show. Love some questions, and we have much better developers than me that can answer if I can in the room, so please go ahead, and would love to have some questions. And there's a mic, yeah.